Thanks, Bianca, and good morning, everybody. I'd just like to echo Bianca's sentiments and say thank you very much for coming along this morning on this wet Saturday morning. I'm sure some of your plans got delayed as a result of the weather. I'm glad you chose us as an alternative. Welcome. So, yes, I guess, first of all, a little bit about me. I started my aviation museum career back in 1986 as a technical apprentice at the Royal Air Force Museum in the UK. Spent 20 years as part of their aircraft restoration team. Undertook some wonderful projects, assisted with some wonderful projects, some major museum capital expansions, and then emigrated to New Zealand in 2005 with my family. I spent a year at MOTAT as head of conservation, before then coming to the Air Force Museum in 2006, initially as registrar, then as curatorial officer, then a short stint back in the UK for a couple of years, had to return for some family stuff, and I did a couple of short-term, fixed-term gigs with the Imperial War Museum and the Haynes Motor Museum, which was great fun. And then back here in 2018 for the position of collections manager. So it's been almost 40 years in the business, and it's been a wonderful journey. And I get to work with some amazing people. I head up the collections team here, our team of dedicated and capable museum specialists and volunteers that help to care and conserve our wonderful collection, and it's an absolute privilege to do that work. So as Bianca said, I'm here this morning to talk to you about our Vickers Vildebeest project. NZ102, the last Vickers Vildebeest. So we'll start off with this wonderful image. So the New Zealand government purchased 12 brand new Vildebeests in the mid-1930s. The first time that they'd purchased a sizable fleet of aircraft, really. They'd purchased aircraft in one or twos before then, but purchasing 12 brand new aircraft was quite a step forward for them. Quite a commitment. And here we see the first of that group of 12 aircraft at Brooklands, the Vickers factory in Surrey. And the controls of that aircraft there is Vickers test pilot Mutt Summers, who was great friends with Barnes Wallis of Dam Busters fame, who was a Vickers design engineer. And we'll see a little more of Mr. Summers shortly. But what that photograph really shows you is the sheer scale of the aircraft. It's just about as big as a single engine biplane got in terms of aircraft design, certainly UK aircraft design of the time. It's a design of the interwar period. So what we mean by that is the end of World War I and the start of World War II. We're talking about a 20-ish year period where aviation technology moved on at great pace. And I guess to put that into context, we're talking about a period that started with aircraft like this, the Sopwith Camel, almost entirely structurally made out of wood and covered with fabric, and a period that ended some 20 years later with aircraft like this. All metal, monocoque construction. If you want to put it in terms of figures, the Camel had a top speed of about 180 kilometres an hour. The Mark I Spitfire, almost 600. So in 20 years, technology moved on at a massive pace. And when you look at the Vildebeest, it's a bit of a mixture. It's a biplane, a lot of fabric-covered surfaces, but it's almost entirely metal in construction. So it's a sort of a late interwar period aircraft with some of those alloys that were being developed, those lightweight, strong alloys coming into play, but still a frame type structure, just like the early wooden aircraft. More aluminium panels, but still a great deal of fabric covering. Of course, the wings is almost entirely fabric covered, much of the fuselage, tail surfaces, fixed undercarriage. But yes, you can see the chap there on the wingtip. I mean, I know they say people were shorter back in the day, but let's assume he's maybe somewhere between 5'6" and 6 foot. So what's that in metric? Sort of 1.8 metres to the wingtip. 4.5 metres to the top of the upper plane there, so an absolutely monstrous thing. You can't see it in that photograph, but part of the reason for that is the size of the propeller, the ground clearance required for the propeller. There are also some design elements in that it was a torpedo aircraft, and high ground clearance for the loading of torpedoes was also factored in. But the thing, of course, with wooden propellers is that their pitch and their diameter is fixed. When propellers were invented that had variable pitch, propellers became a universal fit. They could go onto a whole range of engines. But with solid wooden propellers, their pitch and their diameter is set to give the optimum performance to the engine that they're mated to. So you don't have a choice. So to give the optimum performance, the propeller had to be a certain diameter and a certain pitch. And so that was one of the contributory factors to why the Vildebeest had such a high ground clearance. This is wonderful. So before I press play, it's a YouTube clip, so I'm afraid there will be the obligatory advert at the beginning, but it won't last long. This is an original piece of Pathé newsreel of Mutt Summers, the test pilot, Vickers chief test pilot, demonstrating NZ101, the aircraft you saw in the first photo, to an assembled group of New Zealand diplomats and important people at Brooklands to mark the delivery of the first, or the completion of the first aircraft. It's silent, so we did think about hiring a piano player so we could have some Keystone Cops type music over the silent movie, but okay, let's see how we go. Let's hope the technology doesn't let us down. Okay, I've killed the sound so you don't get the... I've been told I have to say that alternative holiday providers are available should you wish to. We're not sponsored by these people. So here we go. Things to look out for. A little New Zealand flag attached to the starboard rear interplane strut there. No, it's actually started externally on the starboard side of the fuselage. A platform would come down and someone would stand there with a starter handle. Yeah.
Restore all these things.
Just proving to the assembled diplomats that the aircraft do actually fly before you take it. And as you'd expect from Vickers chief test pilot, almost a perfect 3-point landing. Pretty close, but... The darker areas that you can see on the fuselage are the alley panels, and the lighter area is the... I wonder what the pilot's signalling there. So I'm sort of going like that to somebody. And I wish we knew what these guys were saying. But yeah, as I say, that there's no sound with this movie, sadly. Yeah. A couple of journos over on the side there frantically taking notes. And the pilot's had enough, he's off. Got another 11 to test fly. Yeah, so just a wonderful piece of film there that relates to how important it was for New Zealand to take delivery of this fleet of 12 brand new Vildebeests. I don't know if it was normal for foreign governments to send their diplomats to take possession or have some kind of ceremony to take possession of their new aircraft, but it's great. It's great that that survived as well. So if we look at the Vildebeest in RNZAF service, in the image there's the very same aircraft that we just saw being test flown at Brooklands, NZ101, now on the other side of the globe, being assembled at Hobsonville, having been shipped over to New Zealand. So in total, New Zealand had 39 Vildebeest aircraft, 12 initially newly purchased, and then 27 ex-RAF aircraft were sent in 1940-41 to make up the numbers. It served for, 8 years? Not very long, really. And that comes back to that sort of the rapid development of technology. I mean, only 3 years after those Vildebeests were received, there were New Zealand crews in the UK to collect Wellington bombers, which was a whole different kind of aircraft again. Still fabric covered, obviously, but a very different aeroplane. Just 3 or 4 years later, moved completely away from, you're talking medium monoplane bomber, capable of carrying much larger bomb loads, much further. And so in a very short period of time, after they arrived, these aircraft were becoming obsolete. Certainly in terms of what they were originally, their offensive capabilities. They really were put to training use almost immediately after arrival. Pretty large and ungainly pilot trainer, but nonetheless, that's what they were used for. And of course, towards the end, the target towing, which a number of them were used for after others had been scrapped. So 102 specifically was built as a Mark III at the Vickers factory, shipped on board the Rangitata, arriving in April 20th, 35. So when we take on a restoration project like this, it's not just about the engineering process. There's also a curatorial research process that follows alongside, really, because that can often contribute to filling in the holes of information that you have. We talk a lot about the fact that we don't have engineering drawings for the aircraft, and that's obviously a key thing. But there are many, many other ways of gathering information to help us put this aircraft back together. And so one of those things that we research are the movements of the aircraft. Can we find any touch points between this aircraft and particular events, between this aircraft and particular individuals? And all of that helps to build up the picture. So that research is still ongoing, but based on the research we've done so far, here's a few bits and pieces of what we know. So it was first flown 17th of July, 35. Lots of photographic evidence of it being at Wigram from early 38 onwards as part of the flying training school. Then to Nelson in 1940, and on the General Reconnaissance Squadrons at Omarka in 41. During that period at Wigram, it had a bit of a mishap. This was an accident on takeoff on the 12th of February 1939. They did right the aircraft and completely repair it. No detail, we haven't been able to find out any detail on how extensive those repairs were, whether it was re-winged or just the wings repaired, we don't know. But it did live on to fly another day. Then in December 41, it was at still at Omarka. Then Gisborne from 43 onwards, early 43 with number 8 General Reconnaissance Squadron. Ahakia in 43. Really essentially for disposal. It was pretty much finished with at that point. Struck off charge, reduced to produce, basically means stripped of anything that was useful or was applicable or relevant to another aircraft type. So instrumentation, wheels, tyres, that kind of stuff. The remains were then dumped at Martin in late 44. Recovered by the Museum of Transport and Technology. We're not sure exactly when, we think sometime in the mid-1970s. MOTAT had a very active, well they still do, very active volunteer cadre, but back then they would jump into a truck and fly all over the country and recover remains from dumps and out of the bush, crash sites, that kind of thing. And good job they did, because of those efforts we now have these sort of projects. And in 1982, it was exchanged with the Air Force Museum for the construction of a replica Mosquito wing. So when you go to MOTAC, you look at the Mosquito that they have on display, the wing is actually it's a replica. It's not structurally accurate in terms of what a Mosquito wing should be, but it's good enough to be able to display the aircraft. So that was made here over a period of 18 months, and the two things were exchanged. So while 102 was serving with the RNZAF, it was known that it took part in a 5-aircraft formation to mark the opening of Wellington Airport, June 38. And there it is. No idea which one it is. I don't have a magnifying glass that good. But it's one of those 5. It looks like they're flying in a bit of a loose V formation. But anybody that's flown into Wellington knows what the winds are like, so I think we can forgive them for being a bit rough around the edges. A great photo there for any vintage car lovers in the audience as well. And on that day, the aircraft was flown by this gentleman. Anybody recognise that person? No? I'll give you a bit longer. Shut up, Dave. It's quite a notable individual in the history of the RNZAF. In an exclusive club of 3 people. Does that give you a clue? No.
Oh, Jesus.
Leonard Trent. He flew 102 on that day for the opening of the airport. So this is where we're making those connections. You know, we have Leonard Trent's logbook, and it's a case of our archive team basically saying, okay, whose logbooks have we got of that period, whose service history we know enough about that they might have been in the right kind of places, doing the right kind of things, that they might have crossed paths with this aircraft, and then, you know, thumbing through and making those connections. And it's wonderful. But, I mean, the engineering side of this project is challenging and exciting. But when you start to make those connections, those social history connections with the history of the Air Force and the individuals that served, it just brings the whole thing to life. And with the RNZAF being a somewhat smaller service at the time, and the fleets being somewhat smaller in number, it's a bit easier to make those connections than, say, you know, with a service like the Royal Air Force or the United States Air Force, which is just a huge organisation. So let's have a look at the project itself, having looked at the history. So as I said, the aircraft came to the museum in the early 80s. Between about 1990 and a couple of years ago, when we really started to take a really good swing at it, it was very much a back burner type project. I think the idea was that they would, you know, we'll get on when we find more information. You know, we'll crack on when we suddenly discover those drawings, or somebody finds them in a dusty attic, or, you know. And in the meantime, we'll just slow time, do what we can based on the evidence in front of us. And they started working on the fuselage frame. Oh, there's a great photo of it actually coming down from Auckland when the exchange was done, being loaded on board a RNZAF Andover for the trip down. I just thought I'd chuck that one in. It's probably out of sequence a little bit. Apologies for that. We have crates and crates of material. We have more material than you need to build one aircraft. So we know we've got material from other Vildebeests, and probably a couple of Vincents as well. There are some areas in the aircraft where it's impossible to tell the difference. The Vincent was a stablemate of the Vildebeest, almost identical in terms of its basic airframe, just designed to do a slightly different role. The Vildebeest was designed purposely for torpedo dropping and sort of coastal type roles, and the Vincent was more of a army cooperation general reconnaissance aircraft. But we have bits from both. But the vast majority of what we have is NZ102. So to a degree, what we've got here is a composite rebuild. We're attempting to build NZ102, but it's inevitable that we might build in components from other Vildebeests and indeed Vincents. And that's the kind of condition that we have, and quantities. Probably, I mean, you can see 3 crates there. We've probably got more like 7 or 8. Loads of interplane struts and 3 sets of undercarriage and that kind of thing. So, some original wheels and with their original tyres. This was early on in the project where we were hoping that we might be able to rejuvenate the rubber enough, just get enough flexibility back into it for them to at least be inflated to shape. We also investigated, there's a technology that agricultural and earth-moving vehicles have where the tyres are filled with a resin, so they basically can't puncture. We looked at that, but the contractor said that the rubber was just too hard. What we'll probably do is use the best 2, but always display the aircraft on stands when it's ready. So I said earlier that some attempts were made to move the project on, and by far the biggest chunk, as you saw as it was loaded into the Andover, with the most physical evidence to hand, is the fuselage frame. So a lot of work went into stripping that down, removing corrosion, replacing material that was beyond saving, and then reassembling. So over a kind of 20-year period, with it being something that they went back to every now and again as time allowed, they got to the point where they had this basic fuselage frame with fin and rudder attached. And during that period, no drawings came in. We didn't find any drawings. We've tried the obvious sources. I'm in constant communication, I say constant, on a 3 or 4 time a year basis with my opposite numbers at the Brooklands Museum, which hold the Vickers archive, and the Aerospace Bristol at Filton that hold the Bristol archive, because one of the drawings we desperately like to get hold of is a proper engineering drawing for the very complex exhaust collector ring for the Bristol Pegasus engine. But like us, they have limited staff resource. They have rooms full of documents that they have neither the time or the staff to properly catalogue. And so what we need could be in there. It could be in there somewhere, and we just keep those lines of communication open. And hopefully I'll get an email one day saying, guess what we found? Probably just as we put it on display. So we need to be a little bit strategic about where we go with this project. You can sink years of money and time into something at the cost of not doing anything else with an unknown outcome. So rather than say, okay, the aim is to have a finished aeroplane in every respect, what we've decided to do is pursue the goal of a full skeletal airframe initially, without any systems or instrumentation or panelling or covering, just a full skeletal airframe, in the hope that while we're working towards that goal, we can get the information we need to take it a little bit further. We're not completely devoid of references. We have some illustrated parts manuals. We have some NZAPs which help you rig the aircraft and check it dimensionally. But engineering drawings are really what you need to be able to manufacture components. And that's what we don't have. So like any project, it began with, let's lay it all out and see what we've got. So this was back in 2021. We know we've got the fuselage. We've been looking at that for years. And we thought we'd get some main plane spars and centre section bits out and just see what was what, see what components were viable, what bits were perhaps no good for anything but patterns, and what components were actually completely useless. And that process went on for a couple of months. We jury-rigged a few bits and pieces together. So you can see that we've managed to position the lower centre section, upper centre section, and the struts that connect them, some main spars and some leading edge ribs. And it was really just a survey. It's just, where do we stand with this? How viable is this? How far can we take this? At the same time, the thousands of tiny little components that were in those boxes, we started to look at whether we could identify them, or at least take from them their part numbers, record those part numbers and see, as information turned up, whether those numbers would mean something. And there's a good example of the sort of buckets of bits that our techs and workshop volunteers are working through. So they're all assessed for condition, numbers taken from them if at all possible. One of the things that does help a bit is that the numbers, the first 3 digits in these numbers relate to a group area on the aircraft. So I can't recall what 258 is, but 258 might be tail assembly or something like that. So it at least gives you a bit of a clue where on the aircraft those bits go. All of the original fixings, what we're looking at here are spacers and bolts and shackles and bits and pieces from the disassembly of the lower centre section, which was the first major structural part that we started to restore. All of these, wherever possible, unless they're really far gone, they're cleaned, corrosion removed, replated, and they will be reused. We strive to the greatest extent to put original material back in. And one of the luxuries that a museum has in restoring a statically displayed aircraft is that airworthiness concerns are not something we need to think about. So notwithstanding a failure of structural integrity that would make it impossible to display the aircraft, you don't want something that's going to sit there and then sag and fall apart. But all of those bits can go back in, down to the last nut, bolt and washer. And that's what we strive to do. If there's no need to replace it, then we don't. So as I said, we started with the lower centre section as the sort of structural heart of the aircraft. The undercarriage is attached to that below. The fuselage sits on it above. The main planes, the lower main planes, are attached to it either side. So it's very much the structural heart of the airframe. So we decided it'd be a good idea to start with that. So what we're looking at here are the centre section is a box assembly essentially, with ribs in the centre and rib nose and tail ribs front and back to give it an aerodynamic shape. And these are the side portions of the centre section. And you'll see in the centre, you can just about see it in the shadow. Just along there's this kind of intricate corrugated web. And this is a really good example of the challenges you face when restoring a one-off aircraft. So that's what that web looks like when it's removed from the spar. When Vickers were building these aeroplanes, they would have stamped out yards and yards of this stuff in the blink of an eye. They'd had a machine that was going bang, bang, bang. If we need any of that, we probably need a couple of metres. And we have to develop the jigs and the dies and the same R&D work, essentially, that Vickers would have undertaken to stamp out a few metres. And that's one of the challenges you face when you're restoring old things. You don't have the economy of scale of mass production that the original manufacturers would have had, and that soaks up a lot of money and a lot of time. Stainless steel fittings from the ends of that centre section. So these are the fittings where the outer wings join the lower centre section. Original components, cleaned up, repainted, and they'll go again. The condition of some of the stainless steel components on this aircraft are phenomenal, considering that they've been buried in the ground for decades in many cases. There's some pitting corrosion you can see there, but nothing that really would affect the structural integrity of those components. And the quality of that material is just staggering, and all of it is going again. So there we've got those same. This is now the front spar of the centre section, having been stripped, corrosion treated, painted, and reassembled. And there we see the same centre section. This is prior to disassembly in a jig. So you manufacture your jig before you take the original apart, because then when you put it back together, you're putting it back together to the original dimensions. And this was fabricated by the team before they started to disassemble that centre section. So just to orientate what we're looking at here, this is the front spar. So this faces forward, rear spar. You can see we have these ribs here, and every now and again there's a slightly more chunky, what's called a compression strut, which takes more load between the two, the front and rear spar. And here are the wing attachment points. And just to give that a little more context, there's that same centre section back in the jig, following assembly with the main undercarriage attached. It's probably a bit misleading. This wasn't a giant leap forward in the restoration. It was more for alignment, and we went one step further and placed the fuselage on top. And it was really just to check that we were going in the right direction dimensionally, because, as I say, this really structurally is the heart of the aircraft, and the alignment between those three things, the undercarriage, the centre section, and the fuselage, is the correct alignment of those three things is essential in terms of rigging the rest of the airframe. Everything really comes off of that. So that's sort of we did that. It was like that for a few weeks, and then it was disassembled again. And I think at the time everyone went, "Wow, what a great! Just going so well." And then everything got taken apart again, and we said, "No, it was just for a test." But I guess that represents the furthest that we've been able to go at this time. I should probably add as well that over the last couple of years, the tech team have been really busy on other things. You'll know that we've had the Orion arrive, we're soon to have the Hercules arrive, and the guys really have had to focus solely on preparations for all of that. But the volunteers that we have in the workshop, many of whom are retired engineers and very capable, knowledgeable people, have sort of kept it ticking along in the background, particularly around the identification of those parts and working out what we've got and what we don't have. And so I think when we get the other side of the Herc arriving and things settle down for a little bit, we can get the team back on this and take it forward a little bit more and see how close we can get to that full skeletal airframe, which I think you'd agree would be a pretty impressive thing to display, even though it won't represent a finished aeroplane. We've got other things. You know, we've got serious corrosion issues with our Avenger, issues with our Andover. You know, you can put all your resource into focusing on a major restoration project while the rest of your collection is quietly fizzing away, unbeknownst to you. So the team have to divide their time between, you know, very involved restoration projects like this, and then what we call preventive conservation care of the rest of the collection, which involves regular inspections, addressing small issues as they come up. And it's getting a balance, you know, with the resource that you have between in-depth projects like this and that other work, which is also just as important. And I think it would be tempting to go hell for leather and say, no, we're not stopping until we've got a finished airplane. But I think you have to be, as I say, strategic and sensible how you allot your resources to all the work that you need to do. Questions? Yes, sir.